Okay, so today we're going to do 6-1, and the operations on functions that we're going to perform today are adding, subtracting, multiplying, and dividing. There's just going to be a new notation, and then we're going to write and evaluate what are called composite functions. So that's going to be a new notation for you, and we'll go over that together. So we're going to start with the operations. So operations are going to be the adding, subtracting, multiplying, and dividing. In the directions, you're going to be given different equations. So you have f of x and you have g of x. And then you're going to find the indicated function. So this is called f plus g of x. All this means is that you are going to add f of x and g of x together. Okay, so you are going to add 4x squared plus 3x minus 1 plus 6x plus 2. Okay, so we've added polynomials together before, so this isn't much different than what we've already done. You're going to combine your like terms together. So 3x and 6x can combine to 9x. Negative 1 and 2 is going to combine to 1. And then when you are writing the polynomials, you are going to want to write them in standard form when you're writing your final answer. Okay, the subtraction is very similar. Just with your subtraction, you have to remember to distribute the negative. So this means f of x minus g of x. Okay, and if you subtract, you'll often see this in parentheses as a reminder to distribute the negative to the 6x and the 2. So it's minus 6x minus 2. Okay, so then combine your like terms, and then will you guys write your final polynomial in standard form? Okay, so then we should have 4x squared minus 3x, and then negative 1 minus 2, yep, minus 3. Okay, and then for example 2, we're given a new equation for f of x and g of x, and then we also have an h of x, and again we're going to find each function. Now here we're dealing with some multiplication and division. Whenever you're doing division, you have to make sure that you list the restrictions, and that's because the domain isn't all real numbers, so you have to make sure that you list what your restrictions are. So if you have fg of x, this means that you are multiplying f of x by g of x. Okay, so you are going to multiply 6x squared minus x minus 12 times 2x minus 3. Okay, and then you can decide how you want to multiply those. I like to distribute the smaller one to everything in the bigger one. So if you multiply by 2x, you get 12x cubed, 2x times negative x, negative 2x squared, minus 24x. And then we're going to distribute negative 3 to everything, and then line up our like terms. So if you're multiplying by negative 3, you get negative 18x squared. A negative times a negative is a positive. Negative times a negative is a positive. And again, we want to make sure we have that in standard form. Okay, so that's your final answer. All right, for B, we have division. So this is f of x divided by g of x. So you're going to start by plugging in the 6x squared minus x minus 12 on top over the 2x minus 3. If this is factorable, then you do want to make sure that you factor and simplify anything that you can. So there's no GCF, so I'm going to see if we can factor. And then sometimes when you factor, you'll get something that cancels out. Based on this alone, the 2x minus 3, I would try to split this up into 3x and 2x. And if these are going to cancel out, you would want this to be a minus 3. If this is a negative 3, in order to get to 12, you could try the plus 4. And then let's check with FOIL and make sure that works. So 4 times 2x is 8x. 3x times negative 3 is negative 9x. So 8 minus 9 is negative 1. So that does factor. So because that factors, remember, you can divide a factor by a factor. You can simplify that. So your final answer is going to be 3x plus 4. But anytime you have division, okay, any single time you have a fraction. And whenever you have a fraction, your denominator cannot equal 0. And so we always have to solve by setting the denominator equal to 0 and finding what the restriction is. So in this case, your denominator is 2x minus 3. So if we set 2x minus 3 equal to 0 and solve, we would add over 3, divide by 2, and x would not be able to be 3 over 2. So we just have to include that in our answer. So we say 3x plus 4, where x cannot equal 3 over 2. If it was 3 over 2, the denominator would be 0, and we wouldn't even be able to get to this step. Okay, so anything divided by 0 is undefined. Okay, so we would not be able to simplify that anymore. Okay, so based on what we did there, I want you guys to do C and D. Okay, so when you multiply your 2x minus 3 times x minus 4, you just had to FOIL. So you should get 2x squared minus 11x plus 12. Okay, and then for D, for the division, okay, you have x minus 4 over 2x minus 3. There's nothing to factor there, so this actually is your answer along with your restriction. Okay, so you have 2x minus 3 in the denominator. We know that that can't equal 0 because the denominator can't be equal to 0. So you would solve for x. Okay, so we would just say this is your solution where x cannot be 3 over 2. Okay, so anytime you have the division, you just have to have where x cannot be, and then whatever value makes that 0. All right, now we're going to evaluate. Whenever you are evaluating, you are plugging in a value to get a value. So a lot of times you guys evaluate with like f of 1, and you plug in 1 to find out what that's going to be. Again, we are given an f of x, a g of x, and it says that we have to find each value. This is a composition of functions. So a composition is when you have one function within another function. And the best way to do these is to start on the inside and work your way out. So inside you can see you have g of 4. Our first step is going to be to find g of 4. Okay, so if g of x is 7 minus x, you're plugging in 4 for x. You're just going to do 7 minus 4. Which is going to give you 3. And then you're going to substitute. So if g of 4 is equal to 3, then what you're going to find is f of 3. Okay, so now you're going to evaluate by plugging 3 into f of x. And remember, 2 to the third means 2 times 2 times 2. So what's that going to be? 8. Yeah, so then 8 is going to be your final answer. Okay, so f of g of 4 is equal to 8. That's your final. Okay, so for B, we're going to start with the inside. So we're going to find f of 4. This is pronounced g of f of 4. Okay, so if we start with f of 4, we're going to plug 4 into f of x. You guys know what 2 to the 4th is? 16, because 2 to the 3rd is 8, so 8 times 2 is 16. Okay, and then you take that, and now you substitute. So what you're going to find is g of 16. Okay, so you just have 7 minus 16, which is going to give you negative 9. Good, so that's your final answer, negative 9. All right. So why don't you guys try C? And the last step, the number is a little bit bigger, so if you want to use your calculator for that one, you can. Okay, so when you did g of negative 3, what did we get? 10. Yep, so if you have minus and negative, that's going to turn into plus, so you have 10. So that's what you're going to plug in for step 2, f of 10. Okay, so 2 to the 10th should be 1,024. Okay, 2 to the 10th is like doing 32 times 32, because we know 2 to the 5th is 32. Okay, and then for part B, we're going to write our answer as a fraction. So remember that whenever you have a negative exponent, to turn it into a positive, you make it into a fraction. Does that ring a bell? So you put 1 on top, 1 over a to the n. All right, so when you do f of negative 3, you're doing 2 to the negative 3rd, which will be 1 over what? 2 to the 3rd, and then 2 to the 3rd is 8. Yeah. So then in step 2, you're finding g of 1/8. Okay, so 7 minus 1/8. If you want, you guys can find this as a mixed number first, because 7 minus 1/8 is 6 and what? 7/8, right? Because if you have the 1/8, that would make it 7. And then you can change that into a improper fraction by taking the bottom and doing what? Yeah, multiply by the whole number, add 7. Yep. 8 times 6 is 48. 48 plus 7 is 55. Okay, so you have 55 eighths. Okay, and I'd even accept 6 and 7 eighths for that. Okay. All right, so this was a little introduction to the composition that we're doing today. So a composition is when one function is substituted into another function. Okay, these are called composite functions. And then we're also going to be finding the domain of those functions. So there's 3 different notations. All 3 of these things mean the same thing. The most common one you're going to see is this f of g of x. Okay, but you might see it like this. Sometimes people see it and they're like, oh, it's fog. Okay, it is a, it kind of looks like a multiplication symbol that's hollow, but the way you pronounce that is f of g of x. Okay, and then this is the shorthand, just the f of g, and that means the same thing. Okay, so no matter which one of these you have, it's the same process, and we pronounce this f of g of x. Okay, so that's how we say it, f of g of x. And it's not multiplication. Okay, we just saw multiplication was fg of x. Okay, this has that of symbol in there. And what this means is we're going to be substituting. Okay, so this means we substitute g of x. We substitute g of x into f of x for x. Okay, so for that variable. So we're taking an expression, g of x, and we're plugging it into f of x for x. Okay, and I'm going to help you with that setup. Now we're also going to be finding the domain. With the domain, you want to look for restrictions. So you're thinking, okay, what values can I not plug in for x? And that means what values would get me an error? What would I not be able to compute? So one thing you want to watch out for are fractions. Because if you have a fraction, we know that the denominator cannot be 0. You can't divide by 0. Okay, so if you have a fraction, the denominator cannot be 0, and that's something that we'll have to exclude from the domain. Okay, the other 2 are both roots. Square roots are going to be the most common, but it's really any even root. Okay, whether it's a square root or an even root, they both are going to have the same restriction, and that's that you take an even root of what kind of numbers? A negative, because if you do, it turns into what? Imaginary. Yep. And so we don't have any imaginary values here. We're not solving. We're saying what are valid values for x that will get you a real answer. Okay, so you can't take an even root of a negative. You can take an odd root of a negative, and that's just because of the properties of negatives, right? If you have an odd number of negatives and you multiply them together, like if you do -2 times -2 times -2, what do you get? Yep, and that's why you can take the odd root of a negative, but let's say you had 4. This would be, nope, not negative anymore. I added this one in there. Yeah, positive 16. So if you tried to take the 4th root of -16, it would be imaginary, okay? Because you're never going to be able to multiply an even amount and get a negative answer. Okay, so we are given several equations here. We have to find the composite function. And then it says to state the domain of each one. Okay, so when you're stating the domain, once you find your composite function, you're going to ask yourself, oh, does it have a fraction in it, or does it have an even root in it? And if it doesn't have those things, you guys know what your domain's going to be? If it doesn't have any restrictions, all real numbers is correct. Okay, so when we're stating the domain, we're going to write this in set builder notation. That's how it'll ask for it on your next quiz, so we're going to practice that. And honestly, the set builder notation is the simpler notation for this one. Okay, so for f of g of x, what we're going to do is we're going to end up substituting g of x for x. Okay, so because we're substituting that in the equation, I'm going to show you what I think is the simplest way to do this, especially as you're starting out. You're going to plug g of x in for x into f of x. So we really have to start with your f of x here. And what we're going to do is we're going to write f of x without the x in it. Okay, so f of x is x squared minus 1. So we're just going to write parentheses squared minus 1. Okay, we have to plug g of x into this expression. So g of x is x over 1 minus x. So that's what you have to plug in. Okay, so you have x squared minus 1. You're going to plug in g of x, and then you're going to simplify. Okay? So when you do that, when you simplify, remember that you have to square the top and then you square the bottom. So this is x squared over 1 minus x squared minus 1. And then we are going to simplify this here. So if I'm going to do that on the side. We do 1 minus x times 1 minus x. Let's FOIL that out. 1 times 1 is 1. Negative x and negative x is negative 2x. Negative x times negative x is x squared. So I'm just going to write that in standard form. So I have x squared over x squared minus 2x plus 1 minus 1. Now, once you get here, you can keep going. Like, you could make this one term. I'm not going to make you keep going. We can leave our answer like this. Okay, but if you wanted to make that one term, you could. Okay, if you wanted to keep simplifying it. And then anytime you have a fraction, okay, for your domain, you have to take the denominator, set it equal to 0, and solve. So this is a quadratic. You can try to solve by factoring the quadratic formula. This one is factorable. Okay, so if you split it up into x and x, what multiplies to 1 but adds to -2, x minus 1 and x minus 1. Okay, or x minus 1 squared. So x minus 1 equals 0 would give you x is equal to 1. And so this is going to be our restriction. Okay, so it's a fraction. So anytime you have a fraction, the denominator cannot equal 0. If you were to plug in 1, the denominator would be 0, and then that would be an issue. Okay, so your domain is x such that x cannot be 1. You guys remember the set builder notation? So x such that x cannot be 1. It's a rational function. If you were going to graph it, I would have you simplify that. And we have graphed rational functions this year. It's the hyperbolas. Okay, maybe that was pre-calc. We will graph ones like that, but you'll combine them. Okay, so you have for b, g of f of x, and you are going to, again, start with the outside. So you have g of x, and then this is what you're going to be plugging in for x. Okay, so g of x is x divided by 1 minus x. So the reason why we're putting the parentheses in is because that's where you're going to substitute in your f of x. Okay, so then we're going to plug in x squared minus 1, x squared minus 1, and then you can distribute. Okay, so go ahead and simplify the denominator. You can get that done. All right, so when you do negative x squared minus a negative, it's going to be plus. Okay, so then you're going to have x squared minus 1 over. You can either write this as 2 minus x squared, which you'll see it like this if you have the negative x squared there, or you can also write it as x squared minus 1 over negative x squared plus 2. Either one is correct. Okay? Now again, you have a fraction. So anytime you have a fraction, we know the denominator can't be 0. Okay, so we're going to set 2 minus x squared equal to 0. And let's go ahead and solve that for x. Okay, so I would add x squared to both sides, take the square root. When you take the square root, don't forget you have the plus or minus. So your domain is going to be x such that x cannot be plus or minus root 2. Okay, those are the values that make it 0. Okay, for C, I want you guys to try to do the setup. So see if you can make your parentheses and then substitute in the correct equation. Okay, so you're plugging h of x into f of x, okay? So if you're plugging it into f of x, then you're going to start with x squared minus 1, and then the h of x is what's going in place of x. So you have 3x minus 4. Okay, so then you're just going to FOIL this. Okay, so you have 9x squared minus 24x plus 16 minus 1. Were you guys able to get that set up okay? Okay, and then you just combine your like terms. This is going to be your simplified answer. And then in terms of the domain, okay, do you have any fractions? No. Any radicals? No. So then, all real numbers. So x such that x is an element in the real number set is your domain. Okay, do you guys want to try to do the setup for D and then we'll simplify it together? Okay, so whatever you're plugging it into, that's like your shell, right? You are going to write it, except instead of x, you have your parentheses. Okay, so h of x is 3x minus 4. Okay, so you have 3x minus 4, and then instead of x, you're plugging in your g of x. Okay, so now if we're going to simplify, we just have to remember how to multiply a whole number in a fraction. So multiply top by top, bottom by bottom. This is like 3 over 1. So you have 3x over 1 minus x minus 4. Again, this is one where you could simplify it so it's one term. Like you could multiply to get the common denominator. Okay, you can also just keep it like that for this. And then we do have a fraction. So anytime you have a fraction, you got to find that restriction. Okay, so if 1 minus x is equal to 0, I would add x to both sides, which means x can't be 1. Okay, and then I'm going to give you a moment to do E and F, so give those a try. Let's see how we're doing. All right, looking around, it looks like E went pretty well. So you have 3x minus 4. You plugged in x squared minus 1. And then, yep, you just have to distribute. So it's 3x squared minus 3 minus 4. Combine your like terms. And what's your domain? Yay. so let's start with G. So you can put your parenthesis, it's x over 1 minus x. Plug in that 3x minus 4, that's your h of x. And there's nothing to simplify on the top, so it's just going to say that 3x minus 4. Here you have negative 3x minus negative 4, which is plus 4. So when you do 1 plus 4, you can either write this as 5 minus 3x, which I'm telling you sometimes they just do that so it doesn't start with a negative, or you can put negative 3x plus 5, and either one of those are fine. Okay, and then we have a denominator which we know cannot equal 0. So 5 minus 3x equals 0. You don't have to write this out every time when you're doing your homework. I'm giving you that repetition now so you remember, hey, this is why I'm doing this step. I'm not going to have to do it every single time. It's only when you have that fraction. Okay, so x is not going to equal 5/3. So it's x such that x cannot be 5/3. All right, any questions on those? All right, the last couple we're going to do together because they're with radicals. So you have k h of x. So when you're doing the k, you would do the square root, right? And then the x is underneath the square root. You can still put it in parentheses, that's fine. So k of x is the square root of x, but instead of x, I'm now going to substitute in the 3x minus 4. You cannot separate those together, okay? Anytime you take the square root, there is an understood set of parentheses there, okay? You would not be able to simplify. This is your final answer. The best way to prove that to people, because sometimes they're like, well, why can't you do it? Well, it's just like if you had 25 minus 16. If you were to split that up, this would be 5 minus 4, which is going to be 1. But what's 25 minus 16? 9. And the square root of 9 is 3. So those are not equal. Okay, so this is not mathematically legal. And again, it's because there is this parenthesis where you have to subtract before you take the square root. Okay, there's that understood grouping symbol. Now, anytime you have a radical, we said you can't take the square root of a negative number. This is how you have to set it up. You would say that value underneath, which is called the radicand. The radicand has to be positive. We use greater than equal to symbols. If it's positive, it's greater than or equal to what value? 0. So we're always going to take that number underneath and we're going to solve. Okay, so that value underneath is 3x minus 4 is greater than or equal to 0. When you're solving inequalities, it's just like you're solving an equation. The only time you have to worry is if you multiply or divide by a negative, because that's when you're going to switch the sign. And so your domain is just all the values of x such that x has to be greater than or equal to 4/3. Because if it's not, then you would get a negative under the radical, and that would not produce a real answer. Okay, so anytime you have a radicand, you have to set it greater than or equal to 0. All right, so if you guys can set up h. So h of k of x. Okay, so what is h of x? Okay, so if it's 3x minus 4, we're just putting parentheses for the x. Okay, what am I substituting in for x for this one? Okay, good. Now here, when you multiply 3 times root x, it's just 3 root x minus 4. There's nothing else you can simplify, so you're going to keep it just like this. And then again, whatever is underneath the radical, you have to set that greater than or equal to 0. So what is the only part that's under the radical? The x. It's only the x. So your domain is x such that x is greater than or equal to 0. Okay, so I'm going to give you your packet for today and tell you what needs to be complete.